Hey guys, welcome to the Code Mat. If you are new to the channel, please do subscribe. We solve a lot of competitive problems. Alright, problem is product of array except cell. Let's understand what it says is given an array of numbers of an integer where n is greater than 1. So there will be always one element present in the array. Return an array output such that output of I is equal to the product of all the elements of n's except that particular ith element from the numbers. So let's understand with the example. So we have given input as a array 1 2 3 4 and output is for first element it is 24, except the first element we need to do a multiplication for to the all the remaining elements. So 2 into 3 into 4, so it is going to be 24. For the second element, first third and fourth element product we need to do, so it is going to be 12. For the third and fourth it is going to be 8 and 6. The constraint given here is it's guaranteed that the product of the elements of any prefix or suffix of the array fits into the 32-bit integer. So we do not need to worry about overflow of the number. So now let's understand the solution approach. Alright, so here we have given this as an input array. This is our output array. Okay, now the one approach could be we can apply a brute force where you have a two for loops. One is for the your ith index, and you will do a product of the remaining elements. So when you are at I, you will do a second loop, and which will be responsible for the product calculation of the elements. So outer loop, when it moves to the here, it will again take this element as well as these two elements. So what is the time complexity here? It is going to be like there is a one for loop running at outer side, and you have other for loop which is calculating a product for that element. So the time complexity here, it is going to be uh, of n square. Okay, and if we go back to the problem, it says please solve it without division and in O of n time complexity. So here the expectation is to solve this in a linear time complexity. So we need to iterate it only once and we need to get the result. Okay, now the other approach or other solution we can apply here is prefix product array. If we create a fixed product array and using prefix product arrays, we can calculate our result array. So what we will do here is we will calculate two prefix product arrays, one as left and other for the right. So what we will do here is for the when you are at a position 3, we will calculate for I is equal to 3, we will calculate product of all the left element in the left side of the product array. Okay, and same we will apply for the right prefix product array. So when you are at a 3, we will calculate the product array of the right elements. Okay, now what will happen for the first element when you are calculating the left side product prefix array? So we will always define L of 0 is equal to 1. We will start with that, and then we will do a product of when we move to the to the right side, we will calculate the product for the left product array, and same goes for the right product array also. When you are at the last element, we will add 1 to that. So when you are at this position, what we will do is r of length minus 1, will define it as a 1. Okay, so at that point we will define a 1, and then for the rest of the elements we will use uh, the element and we will calculate the product array. So what will be the product array for the left and right is, we will define this as 1, and same goes for here 1. Okay, now here the product array is because we already have 1, so 1 into 1 it will be 1. This one, 2 into 1, so it is going to be 2, and for the last element it is going to be 3 into 2 into 1, so it is going to be 6. Okay, now same goes for this right side product array. When we'll start from here 4, so when you are at here at a position 3, at a position 3, the product array is only 4. Okay, now let's move to the one point to the right, to the left hand side. So it is going to be 3 into 4, so it is going to be 12, and at here it is going to be 2 into 3 into 4, so it is going to be 24. Okay, so this is what we have calculated the product prefix arrays. Now what we can do here, to get the result at the ith position, we can do a multiplication of L of I into your R of I, because if you see any of the point, let's say if you go to the point, this point, this left array indicates that it contains all the product of the elements left to the your ith index. So it contains this portion of the product. Okay, and what right product array gives indication, or it gives a result as product of your this portion. Yeah, we haven't added a 3 into the into the left and right. So if you do a product of L of I as well as R of I, it is going to be your result of I. So your result is going to be directly, you can apply L of I into R of I and we will get a result out of it. So we only need to do one iteration, because calculation of L of I and R of I can be done in O of n. Yeah, and this product also we can do it in the O of n. So overall complexity is going to be only linear throughout the solution. Now let's go back to the code editor and write a code for that. Now let's first define our left and right arrays. Integer L is equal to new integer nums dot length, and the second one is your right array. Okay, now let's define a result array also. Okay, so we have defined all three arrays. Now let's first assign initial values for left and right arrays. So L of 0 we want to be 1, and R of last element also we want to be 1. Now let's iterate over the nums array and create a left and right product array. So for integer I is equal to 1, we'll start from there and we'll go till nums dot length and I plus plus. Okay, so L of I is going to be your whatever the previous element having a cumulative product into nums of I minus 1. So this will create our left product array. Now let's create same way for the right one. Integer I is equal to nums length minus 2. We'll start from the right hand side, and then I greater than 0 or equal to 0. We'll go till that point, and then we need to reduce it. Okay, R of I is equal to R of I plus 1 into nums of I plus 1. So this will create our right array. Okay, now we have created our left and right product array. Now let's iterate it and do product of this two array and create a result array. So we'll go from integer I is equal to 0, I less than nums dot length and then I plus plus. Okay, now result of I is going to be your L of I into r of I. Yeah, so we have created our result array. Now let's return the result array. So that's it in the code. Now let's run it. Oops, there is a typo. Oops, th. Okay, let's run it again. Okay, so we got the result as, or this is what the given input output, and the same as expected output. Now let's submit this code. Okay, it got submitted. So here the time complexity is of n, space complexity, as we are using extra arrays, it is going to be also of n. So that's it in this video. Hope you like it. Please add comments if you have a different approach or you are looking for a solution for a different problem. Thank you guys.